Hi guys, I'm Erin, and I'm a board-certified pediatrician. And today we're going to talk about everything you need to know to make a decision about whether the COVID vaccine is right for you and your family. We're going to talk about what's in them, we're going to talk about how they work, and we're going to talk about how we know whether they're safe or not. So if this is information you're looking for, then you've come to the right place. Okay, so let's get right into it. Let's start by just clarifying. There are tons of different COVID vaccines. There's over 200 in development, and there are 10 that are currently in use right now worldwide. Today, we're going to talk about the Pfizer-BioNTech and the Moderna vaccines because they're the ones that are currently being given in the US as of right now, March 2021. These vaccines are both mRNA vaccines. That means that the functional part of the vaccine is a piece of messenger RNA. What is messenger RNA? Messenger RNA is a short fragment of nucleic acids, kind of like half a strand of DNA. You've probably seen a picture of the double helix of DNA, kind of looks like a spiral staircase. The helix is made of two strands of DNA bound together at each base pair. So if you peel those two strands apart into two separate strands, RNA is kind of like one of those two strands. So, in order to understand how the vaccine works, you need to understand what RNA does inside your body. DNA, it lives in the nucleolus, safely stored away in its own separate bubble inside of each cell. When the cell needs a specific protein made, the DNA section for that protein unwinds so that a special molecule called a transcription factor can bind to the DNA, make a special kind of copy of it, or transcribe it into a single-stranded RNA. This RNA can travel out of the nucleolus into the rest of the cell, where another special molecule called a ribosome can use that RNA template to produce a protein, the protein that was encoded by the original section of the DNA. Amazing, huh? So anyway, after the protein is made, that strand of mRNA that's used to make it just falls apart. It's very fragile. It's actually designed to be very fragile. It's supposed to last as long as it needs to make the protein that the cell needs, and then just break apart into its building blocks so that those building blocks can be used again to make the next mRNA for the next protein that the cell needs. So now you know what messenger RNA is and what it does. Let's talk about the vaccines more specifically. How do the vaccines work? When you get this vaccine administered into your muscle, the little strand of messenger RNA, as it melts out of its protective coating, and I'm going to tell you everything you need to know about that next, as it starts to get exposed, your cells start to pick it up and say, oh look, there's a template. We're supposed to make a protein. And then the ribosome attaches to it. Okay, I know I'm like fully anthropomorphizing all over the place, and I'm fine with it. So the mRNA gets exposed, and then a ribosome attaches to it and starts producing that protein. And here's the magical part. That piece of mRNA codes for the spike protein of the coronavirus SARS-CoV-2. So you've probably seen cartoons of it. The viral capsid is usually gray, and it has little red suction cups sticking out of it. And I'm not sure why everyone's decided that that's its color scheme, but it's remarkably consistent. So anyway, those little suction cups are the spike protein. Your body starts making the spike protein just like those little red suction cups that were coded by the mRNA template inside the vaccine. So once your cells produce that little spike protein from that mRNA, that spike protein gets presented on the surface of the cell where it's designed to go by the virus. Once it gets there, it gets picked up by your immune system and recognized as a foreign protein. Then your immune system starts making antibodies to this little foreign protein that it can save for later. And the whole process takes about 2 weeks, from the moment that you get the injection to the time when you have the antibodies that you have saved for later. So after that 2 weeks, if you get exposed to the virus, your body immediately recognizes that spike protein from before, and it kills the virus before it has a chance to cause significant disease. So vaccines in general are kind of like giving your body a 2-week head start on fighting an infection. Now that we know how the vaccine works, what's in it? So first of all, we have the mRNA fragment, and then there's a lipid coating around it, which is made of 4 different fat molecules that are designed to protect that tiny fragment of RNA. There's also some liquid salts and sucrose, and that's it. That's all there is. And that's because RNA is incredibly unstable. It's designed to fall apart. And that's why we have to ship it and store it at such cold temperatures, just to keep it in one piece. You may have heard that the Pfizer vaccine has to be stored at minus 90 degrees. The Moderna one has to be stored at minus 30, or normal freezer temperatures. And this is incredibly inconvenient for distribution and storage, but it does mean that there's no preservatives in the vaccine because it's just too cold for anything to grow in there. By the time the vaccine got warm enough that bacteria could start to grow in it, the mRNA would have fallen apart long ago and the vaccine would no longer be good. So that's all that's in the vaccine. So now you know what's in the vaccine and you know how it works. And that's a good start. But you probably still have other questions about safety. So what questions are people asking me all the time? 1, how do you know the vaccine won't give you COVID? And you know the answer to this now that you know what's in it and how it works. But just to be thorough, we know that it can't give you COVID because there's no virus anywhere in these vaccines. The vaccine contains just the mRNA that codes for the spike protein and none of the gray part of the virus that causes all the problems. How do I know that the genetic material for the virus won't get incorporated into my DNA? Okay, so I totally get that that could make people really nervous. That sounds like it's straight out of a horror movie from the 50s. And this concern probably comes from the fact that the 2 vaccines that are out in the US right now are both mRNA vaccines. So they contain genetic material for a portion of the SARS-CoV-2. So there's a really simple reason why it isn't possible for it to get into your DNA, and that has to do with where the DNA lives inside your cell. So here's a flashback to high school biology. If you were to go just inside your cell membrane and look around, you'd see a lot of different structures and one ball-like organelle called the nucleus. It's inside that ball that your DNA lives. And the nucleus has channels or pores that allow specific things to enter and exit in a tightly regulated way. Nuclear pores allow mRNA to exit from the nucleus, but don't allow it back in. So when your cell takes up the mRNA from the vaccine, it brings it into the cytoplasm, but it has no way of getting into your nucleus, where your DNA lives. So who can get this vaccine now, and when can kids get it? Right now, it's only approved for people 16 and over, and that's for the Pfizer-BioNTech. The Moderna vaccine is only approved for people 18 and over. There are a couple of ways we go about determining safety and appropriate doses in kids. We won't go into the tedious details, but as you can imagine, it's difficult to do these studies in children. What if you have a specific medical condition, or your child has a specific medical condition? Should they get the vaccine? There is a precaution for people that have had an anaphylactic reaction to certain injectable medications. The thought is that those injectable medications may employ the same fat molecules that are used in the vaccine that could have caused the allergy. But like I said, that's a precaution and not a contraindication. Is it safe to get the vaccine if you're breastfeeding? We haven't done studies in lactating women specifically, so it's not officially approved for that population. That said, there's no reason to think that any of the components of the vaccine should pass into the breast milk or that there would be any effect on the baby from the mother's immune response. On the other hand, if you're vaccinated and breastfeeding, then your baby may be getting some passive immunity through antibodies in your breast milk, although that also has yet to be studied. It's safe to get the vaccine if you're pregnant. So they also haven't done studies in pregnant women, and so it is not approved for that population either. But we do have some information from the pregnant women who found out they were pregnant during the vaccine trials, and there have been no adverse effects on those mothers or babies at this time. We also have no reason to think that this vaccine should have any negative impact on the mother or the baby. For this reason, and because we know that pregnant women have a worse prognosis if they get COVID-19 for a bunch of reasons, and that they're already at increased risk for blood clots already, this puts not only the mother but also the baby at risk. Because of this, ACOG, the American College of Obstetricians and Gynecologists, has advised that pregnant women get the vaccine when they're eligible, after obviously discussing with their OB, of course. Okay, so here's the big one. How can we know it's safe, especially when it came out so fast? Now, I think there are actually probably several different questions that could be embedded within this question, so I'm going to answer them all. The first question, it came out so fast. How could they have created a vaccine so fast without cutting corners? Yes, it came out fast, but these companies didn't have to start from nothing. They had help from Ebola. About a decade ago, when Ebola first started to ramp up, there was an article in the New England Journal of Medicine, I think in 2014, and it argued that we should be supporting the design and creation of vaccine platforms for the development of vaccines, not just for Ebola, but for future pandemics. It was these vaccine platforms and the years of research that went into them that allowed these companies to move so fast when we had a new target identified. Another important point is that mRNA is really easy to make. With most vaccine designs, you have to purify proteins or grow viruses and learn how to hinder them in controlled ways. And these strategies take a long time. With an mRNA vaccine, all you need is the sequence of the protein you want to produce, and you can build the corresponding mRNA sequence in the lab in no time. It's no mistake that the first 2 vaccines that were released were the ones that used this strategy. A side note, that also means that when the virus mutates, it's incredibly easy to modify the vaccine to account for those changes. Okay, but still, this vaccine was created in less than a year, which is incredible, especially when you consider that most vaccines take 8 to 10 years to get to approval. And I know you're thinking, oh my gosh, how did we cut out so much time? That can't possibly be good. But the real question is, why do vaccine studies take so long to begin with? So there are actually several reasons why vaccine trials were able to happen over a shorter period of time. One reason is durability. So we study vaccines for a long time. The vaccine trials take a long time because we want to find out how long the immune response lasts. You get a tetanus shot. You need to know if it's good for 1 year or 5 years or 10 years. It's important for people to know how long the vaccine protects you and therefore how often you have to get a booster. It's an unintended benefit that we can also monitor for side effects in that time. But because we really don't see them after the first 2 months, it's not the purpose of trials taking years and years before applying for approval. Another thing that holds up vaccine development is funding. For a lot of projects, there's support at the beginning when everyone agrees that this is a crisis that demands a solution. But then over time, maybe we get a little better at treatment, or people just get used to it and the panic dies down and the funding dries up. And then the project stalls out while they try to get more funding to move the project forward again. And scientists didn't have to do that this time. They were given everything they needed right from the beginning. And so they were able to work without any of those delays that usually hold them up. Then there's big pharma. So to be fair, pharmaceutical companies that are designing new vaccines, they're usually doing it at their own expense. And it's a very expensive process. So at each stage, they want to make sure before they make the next financial commitment that it's going to be successful. So they go very slowly and deliberately, one step at a time. But this time, they didn't have to do that. They were given guarantees by countries around the world that if you produce a vaccine, we'll pay you for it, whether or not it makes it to market. So in this case, the interests of the governments and pharmaceutical companies and the public were all aligned, which is not always the case. So additionally, while the trials were being conducted, these companies were simultaneously mass producing the vaccines that they were testing. These countries paid them for allotments of vaccines, gambling with different companies that a few would be successful and that it would pay off. And you probably don't need me to tell you that this is not how we usually make vaccines. But this allowed them to have millions of doses of vaccines available and ready to ship out the day that the vaccine received its authorization. But this is how we were able to get vaccines designed and produced so quickly. So the second question is, the trial obviously lasted less than a year. How do we know it's safe in the long run? First of all, the trial was fast for a few reasons. It was fast because it was designed to be fast. The Pfizer and the Moderna trials included many more people than a typical vaccine trial does. This allowed them to get statistically significant data much more quickly. Additionally, the larger your sample size is, the more likely you are to get enough data that the effects can be generalized to the rest of the population more easily. Number 2, the trials were also assisted by the fact that the infection rates in the country were up at the time that the trials were conducted. And this is unfortunate, but it did help them to get the numbers they needed to determine the efficacy of the vaccine much faster. And this is a little complicated, but here's why this is the case. So the phase 3 vaccine trials take a big group of people, like 30 or 40,000 people in these cases, and divide them into 2 groups. One group gets the vaccine, and the other one gets saline, at least in this case. And they administer the shots without telling people which group they're in. And then they send them out into the world and wait for people to get sick. If the infection rate is really low, we have to wait a really long time before enough people get sick for us to hit that threshold that we can take a look at the numbers and see if there's a difference between the 2 groups. In other words, to see if the people with the infections occur more in one group than in the other. But because the infection rates were so high at the time that the trials were conducted, it didn't take long before there were enough infections in that 30 to 40,000 people that we could get the data we needed. So this also helped the trials get through phase 3 really quickly, and how we were able to test the vaccine so fast. But I think what people really want to know is, how do we know if there will be long-term side effects that we just haven't seen yet because it was just made this year? So I think this is the big one that everyone wants the answer to. And you know what? That's completely understandable. This is a new vaccine and a new virus, and humans have evolved over centuries to be cautious about anything new. So if you're saying to yourself, my kids have all their vaccines, I'm not generally opposed to them, but I am genuinely scared about getting this vaccine. And that is totally appropriate and understandable. Throughout history, people who weren't cautious were eliminated from the gene pool. So having a healthy fear about something new is not only totally appropriate, but it's something that's been ingrained in us through millions of years of evolution. So I'm not going to tell you what you should or shouldn't be afraid of. I'm just going to tell you what I know and try to give you all the information you need to be able to make the best and most informed decisions for you and your family. So here's what we do know. Like I said before, mRNA is unstable by nature. It's only designed to last a brief period of time in your body, just long enough to transmit the information from the DNA in the nucleus to the cytoplasm where the protein is made, before it's broken down naturally by our cells as enzymes. In fact, we have to keep the vaccine at such cold temperatures because we're trying really hard to keep the mRNA from falling apart before we can get it into your body. So the actual vaccine components aren't around in your body for very long, like somewhere between 30 seconds and 2 days at the absolute most. And then they basically make the spike protein and then fall apart into the exact same building blocks that your cells use to make their own natural proteins. So there's nothing in the vaccine that's sticking around in your body for weeks and weeks, months and months, waiting to give you some kind of delayed reaction at some future time. In addition, we know from all the prior vaccine studies that have ever been done that any reactions really occur in the first 60 days, although most occur in the first week. These vaccines have been tested in tens of thousands of people so far, but there may be reactions that we haven't seen yet that only happen in 1 per 100 million people or more. But those are by definition pretty rare reactions. If we haven't seen them in as many people who've had the vaccine so far, you're really unlikely to have them. But it's also kind of convenient that healthcare workers are at the front of the line for this new vaccine, because the people who know the most about it and understand the risks and the benefits, and therefore are probably the most comfortable with it, they can be the test patients for everyone else. So by the time it's clear to be given to everyone, another 80 million people around the world will have received them. And you can be that much more confident that we've seen all the adverse effects that are going to happen. But you're right. We don't know what will happen next year, or 10 years from now, or 25 years from now. And that's kind of scary. But on the other hand, we also don't know the potential for long-term consequences of getting and recovering from COVID. We actually already do know that there's a portion of the population that we're calling the long haulers who seem to have some kind of autoimmune, chronic fatigue-like response that's lasting much longer than the acute infection, and it's no fun. There have been cases of myocarditis that's affected some elite athletes and even people not sick enough to require hospitalization. There are effects on your lungs that we really don't know the long-term consequences of yet. Right now, there's no plausible mechanism that we've found for any potential for long-term consequences from the vaccine. But clearly, there's already evidence for long-term consequences from a COVID infection. So I think it's tempting to say, this is too new, it's too scary, I'd rather just do nothing and avoid the risk for now. But doing nothing is its own choice, and it's not without risk. It's just choosing a different risk. So maybe a year from now, everyone who's been vaccinated will grow a third eye. Maybe. We don't know. But we have no reason to think that that or some other scary thing will happen. On the other hand, at the rate we're going, over the next 6 months, probably another 100,000, maybe 200,000, maybe more people will die. And it'll be that much more painful to know that those people almost certainly would still be alive if they'd been vaccinated. So I have my own opinion, but I'm not saying that either one of these choices is inherently bad. I just want you to have as much information as possible when you make the decision, and yet I want you to really know what the most likely outcomes are for each choice. But I do think that's important to remember that as more and more people get vaccinated, we're going to have to be very careful about how we interpret the things that happen after vaccination. And we're going to have to carefully assess what we read or see on social media, because misinformation can be so compelling, and it's much faster and easier for dramatic stories to be spread than the truth. And this is extra important to remember because right now we're prioritizing vaccines for some of the oldest and most medically fragile members of our society. And we know that people have heart attacks and strokes, and people pass away for a lot of different reasons every day. It will happen that people will get vaccinated and then a few days later have one of these events, or even die a few days after vaccination. And we're just gonna have to be cognizant of that possibility and make sure that when we see it happen, that we're processing the data the right way. Because this coincidence of timing has caused confusion in the past. And it takes just seconds for something scary to get shared on social media, but it takes much longer for these events to be evaluated and their causes to be identified. And I just want you to keep that in mind. So if you see something somewhere and you're having trouble figuring out if it's true or not, just drop me a link in the comments or describe whatever it is you read, and I am happy to help you review it. I'm sure this is not going to see enough circulation that I won't be able to keep up. In fact, if it would be helpful for you, just let me know if you'd like a video on strategies that you can use to try to identify misinformation. So if this was helpful for you, then feel free to share it with people you care about, and check back in or subscribe for our next episode, what to do if you or your child's COVID test comes back positive. As always, stay healthy, and don't forget, the best way to take care of your kids is to take care of yourself.